Hello everyone, my name is Ole from trinckle, a Berlin-based software company specialized on 3D printing design automation. In this video we will have a walkthrough in our new industry application, the Fixture Designer. And by the end of this video, I hope you are familiar with the basic principle of our software application. We are talking about relatively simple fixture designs for assembly, for measuring and so on. Great use cases for the usage of 3D printing in the industrial context, but time demanding to design in traditional CAD. And limited to engineers that are experienced in 3D printing and the CAD tools connected. I want to show you how intuitive and fast this design process can be using our Fixture Designer. To start with, let's upload the workpiece which you want to hold in your fixture. You can do this by just clicking the upload command on the column presented on the right side, then selecting the workpieces to upload them. They show up in the rendering and the list on the left. To change the position and orientation of the workpieces, you can do that numerically or just using the gizmo control elements. Let's position both parts nicely connected, slightly above the base plate. In order to add a base plate to the design, we can pick from a few options in this command on the right, and I would choose the perforated base plate for the moment. To learn more about all the base plates, please watch the dedicated video, which gives a brief overview about all the types available. After adding the base plates, a few parameters needed to be defined, such as the width, length, thickness, hole diameter, and the distances between the holes. By the way, there are some shortcuts to switch to left, right, top view from here, and in case you zoomed in or out too much, you can just click here and refit to the screen. Now let's focus on creating a nest structure that holds the workpieces in a stable position. We have a rectangular and cylindrical support elements predefined. We start with the rectangular one and proceed. Now by just holding the control key and dragging the mouse, we can create the support structure for the design. To learn about the different support structures and how to place them, you can find a video dedicated to this in our channel. We can also create fully custom shapes by placing a polyline like this. And even if you misclicked a little bit, it doesn't matter, because you always can correct the outer line of the contour by dragging those points. We might want to fine-tune these supports using the detailed view on the left, adapting parameters like their height level, for instance. You can do this by numeric values or features like a height picker. Another helpful tool we have prepared is the option to add fasteners to mount the 3D printed nest parts onto the conventional manufactured base plate later. By the way, we can still change the shape of the structures by dragging these blue colored markers accordingly. And even if you made a mistake, it's not a problem, you can always undo the last steps by clicking on the icon here in the upper right corner. But let's jump to the most important step. By clicking this switch, we obtain the definite shape of the support structure. The workpieces are subtracted from the nest geometry. And to deal with manufacturing tolerances, we can define an offset for the nest structure. And if a global offset is not helpful for you, you can even define an individual offset for each and every support element. We can easily add non-3D printed components like clamps within our tool. We just select the command, choose one of the options, and then select the point where we want the clamps to touch the workpiece. The same goes for labeling the part. Just select the command, click on the surface of the nest where you want to position the label. In the list on the left, you can define the text, the font size, and other characteristics of the label. We can also add different types of holes in our design. By just clicking here on the button, let's choose counterbore for the moment, and you can enter the dimensions in the list view on the left. To make sure you never lose your work in progress, you can save your configuration status. Use this icon here to create a zip file on your computer. You can restore it later by simply uploading the zip file back here. Last but not least, we want to download the file and feed it to the 3D printer. To do so, we can simply click on the download button and it will create a zip file, in this case including 5 3D printing geometries. Additionally, we can export a PDF which includes renderings of the assembled fixture in total and gives a 2D drawing of the perforated plate and the locations of all fasteners. This will be very helpful for the later assembly of the fixture. We have designed a nice assembly fixture in less than 10 minutes, ready to be printed. To learn more about our software, please watch our other videos where all the functions are explained in more detail. And do not hesitate to contact us in case of any other questions. Our team will be happy to assist you. Also, if you're interested in our software, but you don't seem to find the exact feature, please contact us and we can find a process together to make it perfectly fitting your requirements. Thanks for watching and see you in the next video.